next speaker is Kent Nebergall. So Kent, welcome. Good to see you. So Kent, you've got the Insight lunar-based design to present today. So take it away.
All right, just a moment. So you'll notice it's rather large. This is Lunar Starship next to it, which for a 30-person base seems a bit extravagant, but there's a reason for that. Some years ago, I came up with this grid of all the challenges of space settlement. And one of the themes of the conference seems to be the concept of a Starship Singularity of once we break this edge of this gigantic brick of the space settlement challenges ahead, that suddenly the whole structure will collapse. But, you know, nothing happens on its own. And any one of these issues could become a showstopper. And that's kind of what, as somebody who's been advocating space settlement for, 15 years at least, kind of keeps you up at night. So some years ago, I came up with this idea of cranking all the difficulty levels on that up to 11, basically saying everything that any critic has ever said about space settlement, let's just assume it's absolutely true. Can you still do it? And the answer was yes, you can still do it, including the economics. So this was my entry in a different competition actually 2 years ago. And I'm pleased to say that this is part of a book which was presented by Zubrin to Elon Musk. So maybe someday he'll read it, who knows. But there was one part of that challenge set, which was orbital debris and some of the refueling logistics, which I came up with this solution called Starport, which is essentially a heavily shielded orbital refueling depot, which can also be a O'Neill style ring colony in deep space with a population of around 1,000 people. And when I presented this last year, I said you could slice a section out of this and make it a surface base. And then along came this competition. And so I took a slice out of that and we made it a surface base. So it's rather large for those purposes, but here it is. So bottom line is exploration requires ships, but settlement requires ports. And these are entirely different problems. When you're exploring, you want to be minimalist. You want to carry the smallest cargo possible to reduce the cost of the mission. When you're doing an outpost, you want to carry the largest thing as possible for also reducing the cost of the mission because you want economies of scale going back and forth. You want things to be expandable. You want to use indigenous resources and so forth. So because we've been solving the wrong problem for so many years, we need to rethink the whole thing from top to bottom, which Starship does a lot along those lines. One of the things you need is actually a rather boring concept is, if you're going to build a city, you need a standard brick. You need a standard set of pipes that you're still going to be able to, you build a house and 50 years later, you need to change something in the plumbing. Those fittings have got to fit what was in the plumbing 50 years ago. So these are really mundane, workaday things. But if you want to settle space, you have to have these routine things come up, like standard sizes for machinery and so forth like that. So we want to keep the part count to a minimum. We want, because we have less to develop then, and we want to simplify the design so that we can do things on the surface with local resources, not have to import them forever. So one of the geometries of this was this 22-meter baseline. We can fit 7 starships, fewer if the wings are still attached, within the same geometry as a hangar or enclosure or whatever. But if Elon Musk alluded to an 18-meter starship at some point in the future, you can still fit 3 of those in the same shape. So it's an ideal form factor for that sort of thing, to give it a modular geometry rather than this cylindrical geometry. So we end up with this habitat here. The walls are up to 4 meters thick. They can be thinner, thicker, whatever. It depends on the circumstances, but they can be thickened over time. But they're all using a common essentially take a pillow with a fringe around it, like on a decorator pillow, and a framework, and then take that fringe and nail it into the walls of the framework. This is a hyper simplified version of it. Fill that pillow with moon dust and center it with microwaves. And once it's settled into place, and that's essentially what this construction method looks like, if you want to picture it in your mind. At the top, we have this solar array. It can be photovoltaic, it can be fiber optic to run it down to the greenhouses. It really doesn't matter. We can figure that out at the time. And then one of the nasty things about this is there's no windows to look at the surface. So we want to give everybody the best view. We set up a periscope essentially up here. And the idea there is that cosmic rays can't go down the periscope, only light can. So you have a full view with absolute radio protection from the highest vantage point. Essentially, everybody gets a penthouse view no matter where they are in the habitat. Because the habitat was limited to 30 people, I just took 4 of the lunar starships, which are mostly unmodified from the current design. There's one slight modification to them. And then the rest of them, this is for using the local construction techniques, because we want to, as I said, move from explorers to settlers. We want to have local methods used to create habitats and enclosures. Maybe the current methods only allow 10% of sea level atmosphere, maybe 20, maybe the 100. We'll find out once we have a chance to experiment. And the nice thing about this is you just walk straight outside the door and you've got this regulated space. And then on the sides, we can have garages for the various vehicles and so forth, where they can be readily accessed as well. And that also adds to your radiation protection because everything's one big enclosure like this. Come on, there you go. So this will come up later. This is the highly modified version, but in the initial Lunar Starship version, all we're really doing is we're having a bulkhead door, like a service hatch, between the living hab and the fuel tank, and the fuel tank and the oxygen tank, between these 2 sections. So basically, you can access this in much the same way that Skylab was originally designed, as either a wet lab or a dry lab version. And they went with the dry lab, where they just pre-built all the habitat enclosure inside the 3rd stage and then just launched it as is. This would be, you would take all the equipment for a hydroponics garden, put it in the top part, open the hatches when you landed, take all that stuff down, set up your hydroponics down here. That gives you another roughly 1,000 cubic meters of space for a fiber optic or LED lit hydroponic garden space down below. Obviously, you wouldn't have any patches on the bottom and so forth. But later on, we'll get into this concept of the Star Car, which is essentially a modular rail car for centrifuges. The spaceport uses the same geometry. We would have this sort of elevator system on top, which was analogous to the landing scene on the moon in 2001, A Space Odyssey, but there is a practical reason for it. And then we have hangar space around the outside for up to 6 additional starships, which can be used for servicing or caching propellant to use to refuel on the ascent. The beauty of this system is you can send an unmodified starship to the lunar surface without worrying about the regolith being kicked up with the engines, because there's no path between the engine and the surface material that is less than 100 meters. And in a vacuum, that's going to dissipate dramatically with distance. So the force will not be launching rocks into orbit. The other thing is you would have grabbed a lot of the soil around the base of this facility just to build it in the first place. So it's going to be pretty well scraped down to the bedrock in every direction as well. So it's a relatively safe way to do these sorts of things. And then we would also have sort of a Tesla valve, open topped Tesla valve structure etched into the sides of these flanges here. Basically, the idea there being that the exhaust plume would come down and be redirected against itself in such a way that it would further change the angle of incidence against the surface, in basically to minimize that blast effect on the lunar regolith. The power plant, I'm sorry, this isn't as exciting a slide, but it's a fairly basic system. Low enriched uranium, it's much cheaper, it lasts much longer, it's low maintenance, it's university grade, so there's not much of a toxin level issue or nuclear proliferation issue. And you could eventually go to thorium or whatever, but a box truck sized thing that's 3 by 6 meters is small enough to carry on Starship, and is already being developed for terrestrial modular nuclear power applications. So a relatively low cost option. Radiators here are 19 by 6 meters. This is the same dimensions as those new solar arrays on the International Space Station, and that's by design. The idea there being that in daylight, you're going to potentially pick up sunlight decreasing the effectiveness of those radiators as opposed to at night. It may just be secondary light off the surface, but it's not going to be as effective in the daytime as nighttime. But if you shade them with solar arrays, then you can plug that gap in the solar output and sort of level the output. So the idea here is that we have 12 megawatts per plant, 24 in total. That's way plenty or something like this. So budgeting this out for the LED gardens, that's actually the vast majority of the power requirement. But you can shut down one plant entirely and still have 400 kilowatts constant power on reserve, and you have this huge reserve for industrial applications and so forth. Crew make up in rotations with only 30 people. We would have essentially a base commander who's the equivalent to a pilot in command, or the captain of a ship, where they have absolute authority, but they also have absolute responsibility. So that's worked for hundreds of years on Earth. We can simply adopt that model. Each tower has an engineer who's responsible for the well-being of that tower, both greenhouse and the living facilities. Engineers can overrule the base commander on issues of safety or facility maintenance. We would also have doctors, of course, but those would be kind of lumped in with regular crew. Regular crew, similar to MDRS, Mars Desert Research Station, you would have the ability to you'd have your own projects that you would bring to the moon. You'd have the sponsors projects. You would have those coming in from outside locations, and you would divide your time up between your personal work, assisting your other crewmates on their work, and so forth. So it becomes a fairly egalitarian system for that sort of thing. And then if you are a tourist, you would actually be a guest researcher. If there are only 30 people on the entire planet, they are not going to be serving you pina coladas. This is not going to be a luxury cruise. This is going to be a working vacation, essentially. So we can do that later on, but in the short term, I think it's going to be a more productive thing. And there's also another aspect of this that would be interesting is it costs roughly $3,000 to get a private pilot's license, but it costs $300. The ground school, which teaches you everything mentally to be a private pilot, even if you aren't physically in the aircraft. We could have a similar setup here where you would go to essentially an adult space camp, could be like a 1-year college or whatever, to learn everything you would learn if you were going to the moon, and essentially give you the mental skills that you would need for that sort of thing. And that's a heck of a resume bullet, but it opens it up to people who are too young or too old or have health issues where they could not pass the flight physical, essentially, to go to the moon. So it democratizes that a dramatic amount, and it makes it a more participatory experience for the world. Speaking of economics, this is a highly simplified version, but we only have a few minutes. Sponsorship wave would be a canned example of that would be, you sponsored 1 week's worth of coffee for one scientist on the moon, and in exchange for that, you get a certificate to hang on the wall. And here's the bag that the coffee was shipped to the moon in, and it's a space flown artifact, and it's certified and so forth. And you can show that off going forward to your kids and grandkids that you were part of that whole effort. Collectible wave is of course, idea of selling moon rocks. In general, the first moon rock might be $1 million, but the millionth moon rock might be $1. So each of these things has their own peak and trough of the diffusion of innovations curve, essentially. So it starts out very novel and shoots up, but eventually it becomes mundane. So the idea is that each wave would feed the next wave, but it would be taken over by the next wave. We're building all that into the system from day one, essentially, that each of the hype cycles will, as the hype for one thing dissipates, the hype for the next thing fuels the spending on it. So MoonSpec is essentially, it's like MilSpec or Underwriters Laboratories that UL listed on all your appliances. UL is actually a private company. It is not a government agency or a regulatory agency. Manufacturers send their stuff there, tested, they get their certification that basically says this will not burn your house down. Now, if you are Porsche and 80% of the parts in your vehicle are moon rated, you have a competitive advantage over another manufacturer that has maybe 20 or 30%. So as manufacturing technology becomes more commoditized, you need other differentiators on the market for luxury goods. And around the time that this asymptotic progress happens in engineering is around the time that this inspect thing would be a thing. So it becomes a way to skate to the puck in terms of the problems of industry and the solutions of a lunar base. And then the last thing is epigenetics, which we'll get into shortly. At Earth, let's just say we're a value of 1 for radiation protection from cosmic rays and 1 gravity. The surface of the moon would be down here. You have some radiation protection because the moon's behind you, but you have much lower gravity. Mars is about here. And you can make centrifuge habitats that can basically plug this entire gap in between. So within Earth, we have an entire industry built around taking plants and stressing them a bit to see what their silent genes will say under different stresses. There may have been some ability a plant evolved 12 million years ago that it just hasn't used lately because there hasn't been that sort of climate stress or whatever. Space stresses are an entirely different animal, and we don't know necessarily what those silent genes will do. So this would be a way to open up that whole thing without going into full genetic modification. We're using the genes that are already there and expressing them to show a broader view of the palette of the colors that we can paint with when it comes to selective breeding of crops and so forth to make them more resistant to climate stress or feed more of the world's population or be a better fuel or a better manufacturer of pharmaceuticals. That entire thing is a massive industry because it affects how we eat, how we medicate, how we construct everything. So different species are going to have different ranges when it comes to what kind of stress they can handle. So this also tells us which species we can use for space settlement and what levels of gravity and radiation those things will withstand. So next to the outpost, we would eventually build the centrifuge track. This is kind of the, begin with the end in mind. We would build around this concept. And this is essentially a cross section of that track turned sideways again. For 1 gravity of Earth, we would have a 74-degree angle, but we're not actually going to do that in this case. This is a section of the Mars one that I designed a while back. We would have essentially, James, you said you like monorails. Well, I got 7 of them for you right here. We've got all these magnetic train cars that essentially run in this track around the side. This is the rough layout of how big they would be when converted from a Starship. And we could have a population of 1,200 people in just 1 ring, and that's with one car just being used to go up to ring speed and down to surface speed, and all these locked together, going in the same direction. We would have the ability to transfer between cars. These might just be fused together and not have all this sort of arrangement between. And within this 3,000 meter arrangement, we would get up to about 3/4 of Earth gravity or 3.7 times lunar gravity. 64 miles an hour is a safe enough speed. 50-degree angle, not too extreme, and 2 RPM almost exactly. It's within 1/1000th of that. And that's based on this D-ring core. And this is all calibrated to not make you dizzy, so it could go a little faster if need be, if under proper conditions. So our collective logistic system is we have this in Earth orbit to refuel starships to get out to an L5 point for caching before the next launch window to Mars. And then on top of that, we have this InSight lunar base, which can be used for extracting resources to assist in building these, as well as its own domestic operations. And in conclusion, this modular system can be scaled all the way from 10 people for a small Skylab style outpost to 10,000 people for a large outpost. So it deals with that, what's called the underpants gnome problem, since I think Jeff Greason originally used that metaphor. But, we start out with Starship, and on the other end, we have space settlements, and in between, we have this big question mark. This closes that question mark by taking what we have on the front and moving it all the way to the back with as little drama as possible, and designed to deal with as many of the calibrations of the problems that we will face in the future cranked up as high as possible. If it turns out to be easier than that, then it's a bonus. That's just gravy on top of everything else. So thank you very much. Any questions?
All right. Any questions for Kent from the audience? I have a question. First of all, I love the multiple monorails in a track there. That's great. Although it'd be hard to see out, I think. One of the features of the monorail is you get to look out the window.
Yeah, there's a in the original design, I think I had basically a fiber optic arrangement that would allow you to project views into it. So you'd basically have a big window on down one side because you need a magnet on the outside, but on the inside you can open that up to essentially a periscope window.
Mhm.
So it is feasible.
How would you govern this settlement? I don't know if you went into that very much. How would you give people a
Briefly,
voice?
yeah, essentially it's with 30 people, you would have a bit of a direct democracy as well as a top-down structure. So most of the routine operations, would be the pilot and command model. We might want to also have essentially a city manager model when you go to a larger group. Because the beauty of a city manager in most in some cities like Peoria have this model is it takes all the politics out of governance. The mayor in a city like that is just the chief salesman, so he basically goes out and does all the drama stuff, and the city manager is actually making sure that all the books balance without a lot of the worrying about being elected or whatever. So we may have a system similar to that where you run it almost like a business. You don't have all that sort of drama. I like the idea of the engineers in a each tower being responsible for their little domain and being able to potentially outvote the commander if they have some dramatic, it's like, hey, let's go build a telescope on the other side of the moon, and the people say basically, oh, you could do that, but then our base will lack resources in 10 years and we'll all starve, that sort of thing. So you need to be able to cover those things. You need to have a solid foundation from which to build out. The project management system of you bring your own project or whatever, or you're sponsored, that allows you to have something like a space telescope. There are the organization sponsoring that effort, whether it's a government or a university or whatever, would have their own crews come out, do their work within that facility. And then when the project is done, it's done. The power structure around it does not become a self-flicking ice cream cone.
And what is your background, Kent? I don't know if you went into that.
Yeah, I wrote up the intro and we skipped it because of time. But basically, I'm a business analyst as my day job, but I've been interested in space ever since I was 7 years old and watched Apollo Soyuz, and I was peppering my dad with questions about it, and he was able to answer all of them because, unbeknownst to me, he was a test pilot back in the 50s. So that kind of got me on this train, and I've always been fascinated with space ever since. And I've done about a month's worth of rotations at Mars Desert Research Station. One rotation as commander, and I'm the steering committee chair of the Mars Society. So I've been doing presentations like this for about 15, 16 years now. Oh God, 17. Oh well. Anyway, time gets away from you. I'm not a founding member like you, but I'm grandfathered in.
Well, we're happy to have you here at the Moon Society today. Let's see about your base. How would you make it appealing to tourists if there were a lot of tourists that could choose where they wanted to go on the moon?
One of the beauties of a tourist is that if you are a career astronaut, you have to seriously worry about your lifetime radiation exposure. If you're a tourist and this is your one and done, trophy on the wall sort of thing, you are, and you want to go out and be, the Neil Armstrong in the spacesuit, that works to everybody's advantage because you can basically, part of your tour will be going out on EVA a lot more than the local staff. So you would be trained on going out and building things on the moon, and then you've got lifetime bragging rights that you help build that facility on the moon for the rest of your life and probably the lives of your children and grandchildren. So because at that point it's a historic artifact, so it's probably not going to be torn down anytime soon. So there's that's a heck of an appeal to anybody to have made a permanent mark on something. I once took a relatively low paying job at a major corporation because there are pieces in all 14,500 McDonald's in the US that I helped engineer. So there's leaving your thumbprint on an American icon has a certain appeal to it with beyond finances.
That's an interesting story. Yeah, I also have a piece of all the Microsoft stores because I worked on a project for that.
Interesting.
Let's see. Any other questions from the audience? I don't think we have any. So, all right. Well, thank you very much, Kent. This was great. Thank you for presenting and thank you for attending the conference today.
You're welcome.